Now, we take a look what is the mineral admixture. So minerals admixture can be classified into two. We can have natural pozzolans and then we can have artificial pozzolan. Okay, normally natural pozzolans is the clay and shells, volcanic tuff, diatomaceous earth and also permaceti. And the artificial pozzolans is from fly ash, blast furnace slag, silica fume and rice husk ash. Okay, what is the pozzolan material? Based on ASTM C618, so pozzolanic material is a siliceous or combination of siliceous and aluminous material which in itself possess little or no cementation value, but when it finely divided form and in the presence of moisture would chemically react with calcium hydroxide at ordinary temperature to form compound with cementation properties. So we can have industrial ash. For example, ash obtained from the industry such as fly ash from coal industry. Number 2, slag from iron industry. Number 3, silica fume from silicon industry. So this ash can be used as partial cement replacement or sand cement replacement material. And also we can use agriculture ash. So this agriculture ash comes from the rice husk ash. Okay, it's rice husk ash come from paddy processing industry, and also palm oil food ash come from palm oil processing industry, and also we can have bamboo leaf ash and sugarcane baggage ash. So by replacing cement with certain percentage of these ashes could improve the strength and durability of concrete compared to the concrete produced 100% of cement. So this figure shows from paddy ash to the rice husk ash. So meaning that we need to process of the waste. And then figure also show the extracted palm oil fruit and become palm oil fruit ash. Okay, the role of mineral admixture. Okay, what is the functions of mineral admixture? Number 1, to reduce the consumption of cement for concrete making. And then number 2, improve the strength and durability properties of concrete through pozzolanic reaction. And number 3, saving the cost of concrete construction because we can replace the mineral admixture with the cement. And then number 4 is creating environmental friendly concrete because globally people are towards of the green technology. So what is the pozzolanic reaction? So pozzolanic reaction happens after hydration process started. So calcium hydroxide, which a byproduct of hydration process, will reaction with silica in pozzolanic ash to produce calcium silicate hydrate. So this calcium silicate hydrate will fill in the void existing in concrete, making it denser, thus creating concrete with higher strength. And then reduction of calcium hydroxide, which increases durability. So you can see from this simple understanding, which means that first, cement mixed with water will form calcium silicate hydrate and calcium hydroxide. So we take this calcium hydroxide when mixed with the silica, and it will produce another calcium silica hydrate. So this silica is come from pozzolanic ash. So how the mineral admixture modify the properties of other concrete? Okay, number 1, to lower the heat of hydration and thermal shrinkage. Number 2, to increase the water tightness. Number 3, to reduce the alkali aggregate reactions. Number 4, to improve resistance to attack by sulfate salts and seawater. So what is the popular pozzolan material? Okay, fly ash is the most commonly pozzolan used over the world. So fly ash is used at many high-rise buildings. So, and also it used at industrial structures, waterfront structures, concrete roads, and then roller compacted concrete guns. So, number one, okay, figure 1 show fly ash concrete was used in production building in Chicago after World War II. And then the next figure is show that two grades, 80 megapascal and 60 megapascal of fly ash concrete was used in constructed Petronas Twin Tower in the 1998. So what is the effect of fly ash on hardened concrete? Number one, fly ash contributes to the strength of concrete due to its pozzolanic reactivity. Number two, the continued pozzolanic reactivity concrete develop greater strength at later age, not at initial stage. And then it makes the concrete denser and permeable due to water and gas. Okay, this is the important reminder. Admixture cannot compensate for bad practice and low quality materials. And number two, only certain percentage of admixture added in the mix able to improve the concrete property. So, if we want to use any mineral admixture, then we should conduct the test. And then number three, select types of admixture that can assist toward producing the targeted concrete. So, there are some various of testing should be done. For example, if we are using the fly ash, so we need to know, number one, what is the chemical composition? Number two, the particle size. Number three, the workability. Number four, composite strength. And number five is the durability, is the permeability. So now, let's take a look what is the chemical composition for the fly ash. Okay, number one, based on ASTM C618, fly ash has been classified into two classes, Class F and the Class C. Class F fly ash is known as low calcium oxide fly ash, is generally produced by calcinations of bituminous coal, which means that fly ash with pozzolanic properties. And then Class C fly ash is known as high calcium oxide fly ash, is generally produced by calcinations of sub-bituminous coal or in lignite. So this means that this fly ash with pozzolanic properties and cementitious properties. So which one is good to be combined with the cement? Is it Class S or Class C? So you can see from the testing analysis, the chemical composition contained in the Class F is more than 70%, and then Class C is more than 50%. So particle size of the fly ash, based on the STMC 618, prescribed a maximum of 34% retained on the 45 micrometer sieve. So we can classify that fly ash is fineness determined by blend or BET surface area is 1,700 to 5,900 centimeter square over gram. So finer fly ash has higher pozzolanic activity. Okay, the next is we can have the microfracture through the scanning electron microscope. So we can see that fly ash has a filler effect less effective than silica fuel. So fly ash has a spear shape and we can compare with the cement particles. And then we need to test the pozzolanic activity. Pozzolanic activity is determined in terms of a composite strength index. So pozzolanic activity of fly ash depends on its mineralogy, chemical composition and fineness. So based on specification, 7 and 28 this composite strength of fly ash mix, which means that 20% by mass cement is replaced by fly ash, should be at least 75% of control mix with 100% of Portland cement. So what is the effects of fly ash on workability? So we should conduct the slump test. So you can see that that is the fly ash slump test, and that is the 100% of slump test of concrete. So this figure shows the effect of fly ash on the bleeding water. We can see that that is the reduction bleed water with the concrete mixed with the fly ash compared to the conventional concrete. So this figure shows the effect of fly ash on the permeability. So fly ash content has a lower pressure compared to the 100% of cement. So this figure shows the effect of fly ash on the composite strength. So the higher composite strength, if higher fly ash content. So this figure shows the effect of fly ash on the permeability. So the figure shows that fly ash 30%, the 30% fly ash mix has reduced permeability compared to the conventional concrete. And this is the effect of fly ash on the chloride diffusion. So this table shows that mixed content with fly ash has very low chloride permeability. So it is good. So the summary for today is students should be able to explain the properties of admixture required for concrete mix design.